Bismillahirrahmanirrahim. Welcome to Easy Learn. This is the network analysis. We are discussing the continued topic that is the conceptual schemes in the episode 2. If you remember, we are discussing the atomic theory about the conceptual scheme of the atoms, that whole universe, the substances are made up of the different atoms that are the tiny particles. Atom basically discussed, and in today's lecture we are going to discuss the energy conversion conceptual scheme. Energy conversion, from the name it indicates two words. First is the conversion, that is important, and the conversion of what? Basically energy. This is the second conceptual schemes, and the conceptual schemes means here we are focused on these things. Before going to further discussion, these are our for the understanding, better understanding, we are going to discuss these things. These are the base of all of our technologies. First one is atomic theory, that all the electricity nowadays we are discussing whatever we want to discuss in the electrical pulses or whatever other formats, like where we are discussing the electricity, the electrons are there because the overall charge and whatever these things. That's why we discussed the episode 1. And the second thing we hear, this is the generation side, where we said that, for example, this is there are the two energies, and this is the one type of energy, and this is the other type of energy 1, suppose any energy 1, and this is the energy, suppose we say energy 2. Okay, so two type of energy. Here we have the fixed electrical, because we are treating with the electrical. So according to the first of all, we need to clear one thing. The second conceptual scheme based on our thinking, that is based on the conversion of energy conceptual scheme by our training, because our training, we already know all these things, that in the method of the science we immediately become suspicious of a scheme that claims to create energy. Like sometime from the end of this episode, you can never be suspicious about the things, because you can understand the things. Whenever we are saying that this is the power generation, a grid from where we are connected, the consumers, and suppose here these are the many different consumers that are using the electricity from the power generation. This is the generating station, any, either it's a hydropower or thermal power, coal power plant, any, maybe, I don't know. But here, when we say the energy is generated, basically we are saying the energy is converted, not generated. Actually, the technical means of this, energy is the cannot be created. Remember that. This is the very important last line, is very important. Cannot be created and cannot be destroyed. Neither destroyed nor created, but just it switch from one form to another form. Like in this case, suppose this is the generating station and we are here using the a turbine here, or sorry, alternator here, and we need the mechanical movement of the rotation of the basically alternator, so we can generate the electricity. Alternator basically works on the principle of the Faraday law that we already discussed in Introduction to Electronics season 4, that if the magnetic flux is changed, you remember that d phi over dt, that is the magnetic flux. Here n is the number of the turns, and it is the magnetic flux, so we can also write here phi b. Magnetic flux changing is required, and alternator is a specific position, a specific winding, a specific platform. When we rotate this, easily magnetic flux is changed, and with respect to time, the more speed or number of turns more means more electricity can be generated. But this is another topic, not going in details toward this side. Here it can generate electricity, but we need another energy to convert this energy into this energy, electrical energy. because according to the law of the conservation of energy, energy cannot be created nor destroyed. So it means there are mechanical need, a connection is required mechanically, mechanical coupling is required, or any sources. Here we use a simple word called turbine. Turbine is a simple word that is used. Different types of turbines, different sizes of the turbine, different working principle, different types of operating. Some operate basically on water like hydropower plant, some operate on steam also. Here, electrical energy is the energy converted from some other form. There are the number of the ways in which this can be accomplished. Some are discussed in the today's lecture. Some of the parts in today we are going to discuss in the by one all of these methods. So let's start with the first one. That is the electromechanical. There are two parts. Electro means because we are interested in electricity. So first one is fixed. We are not going to change this one. Electro. Second one is the mechanical energy. Electromechanical energy. Here mechanics involved. Whenever you are going to see a parts that are in motion, that are in movement, these are included in the mechanics. Means robots or the robotic, any machinery that is changing its position, they're moving parts like generators, they are electromechanical. Sorry, mechanical. Simply machines are mechanicals, but if they are operating on the electronics or electricity, they're called electromechanical machines. Electromechanical movements like mechatronics. Anyway, the rotation of the generator, patterned after the invention of the Faraday, we already discussed, produces the electrical energy from mechanical energy of conversion. The mechanical energy comes from the conversion of thermal. Okay, so here, because if we discuss this example, like suppose that this is a generating station. Okay, but instead I am trying here again. This is the generating station. Like in the first line we said that the rotation of the generator that produces the electrical energy from mechanical energy. Here we are generating the electrical energy from the mechanical energy, and mechanical energy comes from where we have obtained this mechanical energy to rotate the turbine. This mechanical energy, like in this case the second point shows that this mechanical energy comes from the conversion of the thermal energy. So it means we have here a thermal energy. So this means that a thermal energy is going to convert into mechanical for providing this mechanical movement. Then again question arises, from where this thermal energy comes from, because we said that energy cannot not be created. So the thermal energy comes from is also converted from another energy, that is chemical energy. So that is the chemical energy. Here C stands for chemical, that is comes from chemical. So chemicals energy is coming from the burning of the fossil, like in the form of the burning fossil fuels, like or chemicals obtained different from the nuclear fuel. Also different types of the fuels that are coming into the chemicals. So different thing means this is a cycle. You can also go beyond the limits, but overall this is a energy cannot be created. It's just changing its position. Same is the case here. If it is mechanical is converted into electrical, and then electrical is utilized for different purposes, like for example light energy. Suppose then lighting the bulbs or any other equipment that produces the glow, suppose we say, then it doesn't means that energy is destroyed in the form of the light, it is wasted. Basically light is also a form of energy. Light, it is just changed, energy is changing its it's what you can say, the right word for this is energy is not created, not destroyed, but is just changing its forms, like in the form of the light at the end, or maybe can convert it into another platform. This can also be achieved by the conversion using hydroelectric generation. Hydro means hydro, whenever we discuss it, means water. Water at the higher potential in the dam usually have a very high potential energy stored in it due to the gravitational forces. Water from enter from this side, leaving through this side, the fins of the turbine are so arranged that when high pressure nozzles, there are special arrangements, there are control systems. When they are perfectly controlled, they definitely rotate this turbine in a particular direction, and then this turbine is mechanically coupled with the generator, which is used for the generation of the electrical energy. So it means that overall this system converts the mechanical energy of the water that is stored in the form of the potential energy, that is converted into the useful electrical energy. So this is a converter, simple. So let's discuss the second type of energy here, that it belongs to the electrochemical. First type again same, electro, second is chemical. This is very simple, means the reactions of the chemicals when done, the energy is produced. If it is in the form of electricity, like in a batteries case, very popular example, acid you can see in the batteries, like the first time of the batteries, it is a very good example. The first time when we are going to insert the fresh acid into the batteries, then charge their plates, the lead looks like quite interesting, and you can see all the process, like bubbles are coming out. This is the chemical reaction, and electricity on the anode and cathode can be seen. Each cell is capable of producing a small amount of, by joining all them in series or parallel combinations, you can generate a huge amount of the overall power. This is not a generation, sorry, this is basically the conversion of the chemical energy. Like in today's episode, I cannot say, especially in today's episode, how can I say that this is generated. Maybe in the next upcoming I forget to pronounce it like that, but in how I can forget. Okay, electric batteries produce electric energy by the conversion of the chemical energy. Very common example is the potentially important use of such batteries in the car, like motorbike or car, rickshaws, etc. Any vehicles that are using these type of vehicles are very interestingly, the chemical energy is converted, and then again the electricity provided to store the electricity in the battery to convert, then what happens in the charging process, electricity is converted into chemical energy, then charges are provided, ions are again, the back reactions is done. Fuel cells are in this, the fuel cells are very good example. Fuel cells, what the fuel cells are doing in this context, basically there is a two type of the fuels in the form of the chemicals that are entered, and in the center, this is the fuel cell actually having an anode, cathode, and in the center there is an electrolyte, hydropositive ions. These positive ions are traveling through this process, while the electrons are traveling through the outside circuit. Whatever we want are flow of electrons. This is called electric current. There are two types of current. Don't forget that the direction are always reversed. We are getting the DC current here, so we are not interested in this direction. Electronic real current, first one is called, that flows from negative towards positive, is called electronic current due to the flow of electrons, because negative always pushes the electron, so it is coming toward the other side. And or you can simply call that conventional current. So sorry, not conventional, real current. This is conventional, that flows from positive toward negative, that we say this is called conventional. This is conventional. Fuel is coming toward this side, and then coming to from exit point is at the bottom of this fuel cell arrangement, and the hydrogen is entered at the anode side, dip, like always in the moisture must be there of the hydrogen. Then the hydrogen reaction started when oxygen coming from the air, means actually air coming from here, then the overall the byproduct also water is water can be seen overall process, and can be collected in the glass. In this practical picture you can see here, this is the fuel cell in the center, and the oxygen, or you can simply say the air, is coming from this fan when turned on for the more air, and the downside there is the provided of the hydrogen also, and the water is obtained. And there are, you can see, if you look closely, there are some wires that are used to connect the run our applications, the energy generated to store in the batteries too. Different applications can be seen because we turn on this system, energy conversion conceptual scheme. This is mostly used in the satellite system, first time used by the NASA practical application, but nowadays it is mostly portable use in the, there are many applications, and modified forms are also using nowadays. Okay, this is the last category, I think so, or maybe third one. Okay, anyway, magneto-hydrodynamic energy conversion. The name magneto-hydrodynamic, here electrical, no, is electric is not attached with this one, but still it is relevant to the electricity generation. Same process, but first we are going to decide. M stands for magneto, HD comes from hydrodynamic, MHD, this is the short abbreviation of this generated. Like the conventional generator, like the Faraday's law generator, relies on the moving of the conductor through the magnetic field to generate electric current. Same is the case here, but it uses the hot conductive. Here, high velocity ionized gas, but hot gas is very hot ionized gas like plasma as a moving conductor here. When they pass through it, this is the input, this is the output, we are generating the electricity. And this is mostly used system in the thermal power plants when the electricity is generated through this process, because the heat is mostly wasted, not all totally heat is utilized by the thermal power plant. So except rather than wasting the heat to the outside environment, why not we pass the heat before leaving the system through this process, so we can obtain some electricity that can be used for many useful applications for later on purposes, and can be stored in the battery too. So this is the last category. How I can forget about this beautiful and renewable energy sources, photovoltaic energy conversion. This is the cell that cannot generate enough energy. One cell is not capable of producing large amount of electric current, but this is a very good, I love this source of energy, because this is there, go green. Simply, my pointer is already in the green state, but anyway, this is a very beautiful source. We can obtain we can, by joining them in series and parallel, we can make the array of the solar cells, and then we can call it as a module. Modules are available in the markets of different silicon, germanium. Basically, the simple energy conversion here, it is also can be seen that light is coming from the sunlight that contains photons of the light. When packets of energy fall on it, it is special type of the diode that can absorb. When the light packets for energies fall on these diodes, basically this is a diode that we discussed in the season 2 of the diode and application, that how this diode can operate actually solar cell. Anyway, the energy when fall in the form of light on this screen, it will going to excite the electrons that are already in the diode, and separating the electrons and diode. And when it is going to separate, then definitely the flow of electrons can be seen if the external circuitry is connected with the terminals. So this is the simple case, but in details there are, the whole book can be written on simple solar cell. How can I explain in 2 lines? Anyway, this is the end of episode 3. Hopefully you like this, and we can continue further discussion in the next episode. So watch, learn, grow. Stay tuned. Allah Hafiz.